actually have to. We covered some of it so that it would make this transition a little bit easier. So here's what I mean. On page 245, problem number 1, you actually can already do this problem. Now, you may not understand the directions, and that's why I want to take a look at it. It says, find the domain. We already did that. Way back when, chapter 1, we talked about domain. Take a look at that problem. Tell me about the domain. Tell me about x values. X cannot be -3. X cannot be -3. So that means graphically, and that's what this section is going to be all about. We're actually going to be now sketching these things. Graphically, we're going to have a vertical asymptote at -3. When you tell me that x can't be something, that means you're going to put a vertical asymptote there. Okay? Now, curves can't cross their vertical asymptotes. This is like a wall. So when the curve gets close to this wall, it's either going to go up or it's going to go down. It doesn't have a choice. Okay? It can't cross it. It doesn't stop. It keeps going forever and ever, either up or down. So that's what the second part of the directions say. The second part of the directions say, as you approach -3 from the right side, and as you approach -3 from the left side, what happens? So again, your notation says the limit as x approaches -3. So as x approaches -3, this says from the positive or the right side, and this says from the negative or the left side. What's going to happen? Well, again, the curve's going to come in, and it's either going to go up like this, or it's going to go down like this. So the answer to these questions are either going to be positive infinity or negative infinity. Now, how are we going to figure out which one it is? Well, we're going to have to plot a couple points, aren't we? So we'll just plot over here, we'll plot -2 and -1, and wherever those 2 points are, it's going to tell us if we're going up or down, right? So here we go. What do I get if I put -2 into my function? 1. What do I get if I put -1 into my function?
2.
What do I get? 1/2. Now, again, you are approaching the asymptote. So as I approach the asymptote, which direction is my pencil going? Up. So this answer would be positive infinity. What you're doing is describing the behavior of the curve around its asymptotes. So you're saying, as we approach this asymptote from the right, we go up. All right, let's see what happens from the left. So we'll put in -4. What do we get if we put in -4? Put it in your function. -4 gives us -1. And -5 gives us -1/2. So again, as I approach the asymptote, as I head toward the asymptote, which direction is my pencil going? Down. Now, we haven't done the complete graph. I just wanted to show you what those directions meant for that first set of problems there. Okay? To tell, you're going to have to plot a couple points, because you don't know if it's going up or down. Could be either one. So you're going to plot a couple of points. All right, that's not so bad. Let's look at number 7 and actually sketch it now. Actually do the sketch for number 7. Okay, so let's take what we already know, what we already learned earlier in the year, and let's put it up here. Now, does anybody remember anything we learned? One, we've already talked about domain, right? Already talked about domain. What's the domain of this guy? x can't be negative 3, so graphically that means you're going to put a vertical asymptote at x equals negative 3. Vertical asymptotes go where x cannot be. All right, anybody remember anything about a horizontal asymptote maybe? It's going to be y equals something. 2. It's going to be y equals 2. Remember that whole thing about this, guys? Comparing those. So your horizontal asymptote is at y equals 2. Does this one have any holes? No, because how do we get holes? We have to factor and cancel, right? We have to be able to cancel, and nothing here cancels. So that's the old stuff. We've already discussed vertical asymptotes, horizontal asymptotes, and holes. Now, in order to sketch this, now we need to add our intercepts. Now, what do we mean by intercepts? Where it crosses the axis, right? And there's 2 axes, so we're going to have Y-intercepts and X-intercepts, right? We're going to cross the both axes. Now, if you're a Y-intercept, that means you're on this line, right? So what do I know about you? If you're somewhere on this line, think about what all these points have in common. What do they all have in common? Their x value is 0. So if I want to know my y-intercept, all I have to do is let x be 0. All right, so let x be 0. What's your y-intercept? Negative 1/3. So I'll plot that point, negative 1/3. That's my y-intercept. Now, what about x-intercepts? They're on this line right here. What do we know about every point on this line? Y is 0. So I'm going to let y be 0. So remember, f of x is y, so 0 equals this. All right, how do I solve that little equation? Bring the x plus 3 to the other side, but since there's a 0 there, it's just going to stay 0, because I'm multiplying that over. So x equals 1/2. So I have an x-intercept at 1/2. Now, as soon as you are done putting your intercepts on there, keep in mind that whatever you draw cannot touch an axis any place except those 2 points. So you're not going to even think about drawing something over here like this. This would be wrong, because see what it does right here? It crosses the axis and you don't have an intercept there. So keep in mind that you can only cross the axes where you have told me you cross. All right, anybody have any idea? This is all the important stuff. If we have to plot some more points, like if we get over here, we can. But anybody have an idea what this might look like? It's a variation of your reciprocal function. Remember your reciprocal function looks like this? It's a variation of that. It's got some things added, subtracted, multiplied, so it's moved around a little bit. But I hope you can sort of see this, at least, that part of it, based on the 2 points that you have right here and knowing they have to be connected. Also know, as you are graphing rational functions, and that's what these are called, they're fractions, they're called rational functions. As you go off the page, you'll get closer to an asymptote. So as I go down, I'm going to get closer to the asymptote. As I go right, I'm going to get closer to the asymptote. Okay, what's going to happen as I go up? I'm going to get closer to an asymptote, right? And as I go left, I'm going to get closer to an asymptote. So any idea what the rest of this picture looks like? That's only one piece of it. Any idea what the rest of it looks like? Think about this. Any idea? It's going to be right up here, just like this. Remember, it's going to approach its asymptote as it goes off the page. So if it's not going up along this asymptote, it would have to be going down. And we said that's not allowed. So it can't be going down, it must be going up. All right, let's try another one. Let's try this one. Okay, what do you think? Any ideas on how to start? We're going to sketch it. That's our job. Factor. And when I factor, and this is an easy one to factor, right? It's the difference of squares. And on the bottom, I can pull out a 2, and then I have the difference of squares again. But when I factor, I'm always keeping an eye out for canceling, right? Anything cancel here? Which simply tells me that I'm not going to have any holes, which is fine. The picture just doesn't have any holes. But it does have a lot of other stuff. Alright, so what are some of the things? Remember when we do our sketch, the things that have to be there are any vertical asymptotes, horizontal asymptotes, intercepts, and holes. Those are the things that have to be there. Now you've already told me there's no holes, so I don't have to worry about that. What about other things? Are there other things? We are going to have a horizontal asymptote. We sure are. And where is that going to be? My horizontal asymptote is at y equals 1/2. Now, does everybody, she's right. Does everybody see that? Let's go right back here. See 1/2? All right, good. What else can we put in here? We know we've got 2 vertical asymptotes this time. One is at -1 and one is at +1. Now notice how Mrs. Ford labels everything. That's what you are expected to do. Asymptotes are lines, so we'll label them with equations. X equals 1, x equals -1. Good. All right, how about those intercepts? Now remember, how do we find y-intercepts? Think about where they are. What do we know about a point on this line? X will be 0. So if I let x be 0, and you can do it in the original, it's probably easier in the original, or you can do it in any of this, it doesn't matter. But if x is 0, y turns out to be 9/2. How do we find the x-intercepts? We let y be 0. So I'm going to come right down here to this equation. I'm going to let y be 0. Now don't panic. This is so simple. Because what happens, okay, to solve that, you're going to get rid of that denominator, right? But when you multiply it over to here, what happens? It's still 0. So you end up with a very simple little equation. Always. What are my x-intercepts? -3 and 3, right? All right, that's it for the important stuff. What do you think? At this point now, you're on your own. You either start drawing or you plot more points. You can always plot more points if you're a little confused. Let's look over here at this section of the graph. What do you think over here? Can you visualize anything? You have this point, so you know it contains that point. You know it's going to approach its asymptote as it heads off the page. So does that make sense to you? What about going that way? Does that make sense to you? How about on the other side? Same thing. Now, if at any moment you are confused and thinking, oh, how did you do that? Plot some extra points. Put in 2, put in 4 into your equation. Plot some points. Now, I got the middle section I have to worry about. What do you think's going on in the middle? You got a parabola. Now, I want to talk about that. You are exactly right. You got a parabola shape in there. You're exactly right. But I want to remind you or tell you for the first time that you can have parabolas opening up, you can have parabolas opening down, or you can have squiggly things in there like this kind of thing going on. Okay? How do I know with beyond a shadow of a doubt that this is a parabola opening up? What? Well, it's bounded by those asymptotes, but how do I know it's not a parabola opening down? I could have one opening down. How do I know that, Olivia? Boy, I don't know about that, because when I start putting all the rest of this stuff in there, some of those rules change. Okay, so I'm not going to say yes or no on that, because I truly don't know, but the rules do change. Things change when you start adding a bunch of junk in there. Now, there's another reason. Absolutely. Other Olivia. That's a great point, but we need to talk about that too. You can actually cross horizontal asymptotes. There are curves, believe it or not, this is not one of them, but believe it or not, there are curves that will do this. You can cross a horizontal asymptote. You will never, ever touch a vertical, but you can cross horizontals. Nope, there's something else. Oh, that's what Olivia H said. And I don't know about that. That's the one I'm just not sure about. Okay, if this were a parabola opening down, what would happen right here and right here? Those would be X-intercepts, right? Have you already found the X-intercepts? Were those two part of it? No. So therefore, the minute I put that point up there, I knew every point had to be up there. There's no way any of that can come down because you can't cross the x-axis. Okay? All right, let's try another one. This is all section 2.6 is. Now, we do have one more additional component to add, but I want to do another example first. Let's try this one. So here we go. We're going to sketch this. That's our job. I'm going to draw a picture of this guy. Okay, so next time we have class, we're going to have a quiz. I'm going to stick a problem on a piece of paper, and I'm going to say go to it. So how are you going to start? You're going to factor everything. So we can take a 3 out. And we have the difference of squares if I pull a 3 out, right? Don't lose the 3, keep 3. Oh boy. Now we're going to have a hole. So we are actually going to sketch 3 times x plus 3 over x minus 1. That's what we're actually going to draw a picture of. But before I get too far into it, I want to go ahead and graph my hole. I have a hole. The hole is a point. And where will that point be? What did I cancel out? I canceled out a 3. So my hole will be at 3. That's what I canceled out, right? Now, comma what? How do I find the what? I plug 3 in right here. Right here. So I'm going to have 3 times 6 over 2. So the hole is going to be at 3 comma 9. So I'll label that. Right there it is, so I don't forget about it later. There's my hole at 3 comma 9. Now, does everybody remember all that? The hole is the x value is what you canceled out, and then you plug that into your new problem to get your y value. Okay, so now our beady little eyes are focused on this. Okay, we're not looking back up there now, we're looking here. What can you tell me? I need asymptotes and intercepts. What can you tell me? Can't equal 1, so I'm going to have a vertical asymptote at x equals 1. Everybody see that? I have a horizontal asymptote at y equals 3. Now you can get that from the original problem, but you can also get it right here. Do you see that? All right, what about intercepts? Think about your y-intercept. What are you going to do to find your y-intercept? You're going to plug in 0. So when I plug in 0, what do I get? Plug in 0. What do we have on top? 9. What do we have on the bottom? So when I plug in 0, I get negative 9. And what about my x-intercepts? How do I find those? Set it equal to 0, so I'll set this equal to 0. So 0 equals 3x plus 3. Okay, but I'm going to bring this over. Still 0. I'm going to divide by 3. Still 0. So where's my x-intercept? Negative 3. Now, I showed all my steps there. Some of you are going to do that in your head. That's fine. Alrighty. That's all we got. That's all the important stuff. Everything else now, you're on your own. I think you have enough information to sketch it, but if you're unsure, plot some more points. Keep in mind, though, that these 2 dots have to be connected. Keep in mind that your asymptotes are kind of a frame that holds the curve. So with that in mind, does that look about right to you? That's half of the picture. What about that side? What's going on over there? You got the exact same thing. Looking like that? That hole is just like you just jump over it. It's like a skipped point. But it's part of the curve. It's in the flow of the curve. You okay with that? Thinking, oh, this isn't so bad. No, it's not. So let me throw you a little bit of a curveball. Not a bad one. I'm going to do problem 43 now in this section. Problem 43. Bless you. And looking at problem 43, does anyone see anything that's any different about it? I mean, it looks kind of about the same thing, but there's a difference here. Anybody see what it is? The power on the top is bigger than the power on the bottom. Okay, now wait a minute. What implication does that have? Maya?
Does that make your Y-intercept either 0 or undefined?
Okay, not my Y-intercept. You're thinking horizontal asymptote.
Yeah.
And it does affect the horizontal asymptote. This problem has no horizontal asymptote. Now, it does have what we call an end behavior asymptote of a different style. And horizontal asymptotes are sometimes called end behavior asymptotes. What does the curve do at the ends? What does it approach at the ends? This one is going to have an end behavior asymptote that is slanted. It's going to be what we call a slant asymptote, okay? But everything else about the problem is the same. So let's do all that part first. All the part we know what to do. Let's do it first, and then we'll deal with the slant asymptote. So, tell me what I can put in my picture, what you know for sure is going to go in there. X can't be -2, so we'll have a vertical asymptote at -2. Good. Absolutely. Any holes? Well, I probably should have done this first. I probably should have factored to make sure, right? But I can tell it's not going to, but you want to make sure that if something cancels, you want to do that first. But nothing cancels, so we're safe. So no holes. How about intercepts? How do we find an Y-intercept? Plug in 0 for X, and you can do that since nothing canceled. You can do that at the original, or you can do it here. I think it's easier to do it in the original, because if you put in zeros, all that's gone, and all you have left is -3/2. So my Y-intercept is -3/2. X-intercept. How do I find X-intercepts? Set it equal to 0, so I'm going to solve this equation. But I know the denominator is going to disappear, so basically I'm just solving the numerator, right? You probably figured that out by now. So I got 2 of them. Where are they? -3, 0 and 1, 0. All right, so far so good. Everybody okay up to this point? Because now the new stuff comes. To find your slant asymptote, and how will you know when you have one? Top has to be bigger than the bottom, okay? So to find your slant asymptote, I want you to do this synthetic division. This is a division problem, just divide. So you're going to put the -2 out here, and 1, 2, -3, and you're going to do the division. Now, yesterday, we were hoping like heck we'd get a 0 here, right? That's not what this is about. This is not about finding factors. If this thing had common factors, we would have canceled them out already. ignore the remainder. It doesn't matter what the remainder is, ignore it. The important part is right here. What does that stand for? What does that say? What does that represent? X plus 0. That says X plus 0. Y equals X plus 0 is your slant asymptote. So when you do the synthetic division, this part right here gives you your asymptote. What does Y equals X plus 0 look like? A line going through the origin with a slope of, not a slope of 0, a slope of 1. So up 1 over 1. So it looks like this. It's your identity function. Yep, that's your identity function. Now that won't always be the case, but it is in this problem. So now I draw in my dashed line, Y equals X plus 0. And I am going to connect my dots, remembering that the asymptotes are the framework. They hold the curve. Any ideas what this thing might look like? Now remember, these two dots have to be connected, okay? This seems to be going down. Would you agree with that? I mean, it's kind of going down, okay? But it's got to follow this asymptote down off the page, so there we go. Now this way it's going up, but it's going to follow that asymptote up off the page. So this piece is framed by these asymptotes. See it? I should do my asymptotes in a different color. You could see it better. Now I got a point over here. What do you think that curve that contains that point is going to look like? Do you think it might go up along that asymptote like that? And then down along this one like this? And if you're a little bit confused, think of that. All the ones we've done so far have been variations of the reciprocal function. So you've got these pictures kind of in opposite corners. Well, this one's turned on its side, but can you see these are opposite corners from these intersecting asymptotes? All right, you may have a question about that. Oh, let's try another one. That was 43, let's do 44. Will this one, number 44, will it have a slant asymptote?
Yes.
Yes.
I'm about to switch seats so I can be closer to the trash can because I keep having like blow my nose.
Oh, okay, okay. Yeah, well, take the Kleenex with you, take the box of Kleenex with you. I thought you were saying you had to be closer to the trash can because you were gonna throw up.
No, it's just my nose.
In that case, I would have scooted over myself.
No. I had 8 days where everywhere I went, I had my pan with me. I got it. Well, first of all, I didn't move very much for those 8 days, but like when I went to the bathroom, I had to take my pan with me. It was awful. Okay. Step 1. I really want you to get in the habit of factoring first, because if something cancels, and I don't think anything's going to cancel here, but if something does, you have to take care of that first, because that kind of changes a lot of other things. So try to get in the habit of factoring first. Okay, it didn't matter. So now let's just fill in what we can. All right, so tell me what we've got. Vertical asymptote at 3, x equals 3. Okay, and then horizontal asymptote. Oh no, we don't have a horizontal asymptote. We're going to deal with that. We're going to do it right now. How do we find our slant asymptote? We divide. So out here I'll put a 3. And here I go. And I'm not worried about a remainder. It's totally irrelevant. Forget it. I'm worried about what's left here, my quotient. So did I divide right? Okay. And what is my quotient? What does that represent? That's the line y equals x plus 2. X plus 2. So that's my asymptote now, my end behavior asymptote, my slant asymptote. That's a line with an intercept at 2, right? And a slope of 1. So, alright, here we go. So we got intercept at 2 and a slope of 1. So it's going to look like that. So before I even put any points on there, you got 4 sections. The curve's divided up into 4 pieces because that's what 2 lines do. So you kind of got this area here, and this area, this tiny little area up here, and this area, right? You're gonna have a curve in 2 of those areas. All right, so let's see if we can figure out where it's gonna be. How about intercepts? Do I have any intercepts? I have an intercept, what? I got an x-intercept at 2 and an x-intercept at -1. Now, some of you are already doing that in your head, and that's good, because you know when you set this thing equal to 0, the denominator is going to disappear, and you're just solving the numerator, right? So my intercepts are going to be at 2 and -1. What about my y-intercept? Let all these be 0. What's your y-intercept going to be? 2/3. Well, you know what one part of the graph looks like. Look at all that information you have. Doesn't it make sense that it would look like that? I don't have any points anywhere else, so I'm either going to plot some or I'm going to use my common sense. If the picture were in this section, it would have to look like this, because it's framed by its asymptote, so it would have to follow that one and follow this one. Why is that not possible? It can't cross the x-axis, so it's not this piece, it's not here, for sure. Alright, if it were over here, it would follow that asymptote and follow that one. Is that possible?
No.
No, because now you're crossing both axes and you're not allowed to do that. So what's the only other option? It's this little tiny space right up here. That's where it is. That's where it is. That's the only place it could be. But if that doesn't make sense to you, what are you going to do? Plot some points. There's no excuse to not have a picture. Plot points. It takes time, but do it. All right, now we're ready for the Big Daddy problem. Here we go. Last one. Last one of the day. If you can do this one, you are 2-6 champions. All right, so here it is. Oops, that's not a 6. That would be bad. That's a 10. just before this last problem, I urged you to do what? Factor. So let's see if we can factor. Oh my gosh, look at that numerator. Shades of yesterday's test. It doesn't group. So what are we gonna have to do? We're gonna start guessing, right? And our PRRs, our factors of 8. So let's start guessing. We wanna break down that numerator. So what do you think? Anybody find the number that works? 1 works. How lovely. So I'll divide it out. Now this division is not my Slant Asymptote division. This division, I want to get a 0 because I'm trying to factor my problem, right? So this is not the other kind of division. I mean, it's the same kind of division, but the objective's different. Here, I'm trying to get my numerator factored. Since 1 worked, one of my factors is x minus 1. Would you agree with that?
Mm-hmm.
Now, this is what's left when I take that factor out. What is it? Evie, you okay?
Yeah.
Okay. What's left here? X squared plus 2x minus 8?
That's a factor too.
Does that factor?
Yes.
Patty, how does that factor?
One of the factors is x plus 4, the other is x minus 2.
Are we going to agree with Patty?
Yeah.
All right. And then my denominator
Difference of squares.
is the difference of squares. Oh my goodness.
Winner.
Now we have some canceling. So our new problem is this, and we have a hole at 1 comma something. Right? Now don't say 1 comma 0. It might work out to be that, but you don't know. How do you figure out 1 comma what? Plug it in the box up there. So when I plug 1 in the box, I get 5 times negative 1 over 2. Did I do that right? If I put 1 in. So what's my y coordinate of my hole? Negative 5/2. Sketch it right here. All right, so I have a hole at 1 comma negative 5/2. Okay. Now remember, that's the problem you're graphing now, okay? So what else do I have from that box right there? I have a vertical asymptote at x equals negative 1. I am not going to have a horizontal asymptote, right? But I will have a slant asymptote. And where will that slant asymptote be? Well, I have to divide, right? So I'm going to divide by negative 1. And now I need to FOIL all that together. I had it over here before Patty factored it. So that's what I'm going to divide into. And again, the remainder is not of any significance. Where is my end behavior asymptote, my slant asymptote? At y equals x plus 1, which is a line with a y-intercept at 1 and a slope of 1. So those are the two lines now that are gonna contain the curve. Don't start drawing anything yet, there's a couple things missing. What do we still need?
Intercepts.
We need our intercepts. So go back to the box. What can you tell me about intercepts? Y-intercept is 0, I think it's -8. Of course, I'm gonna put it down here. Not a room. Everybody okay with that? 0, -8. How do we find a y-intercept? We let x be 0. How about x-intercepts? Do I have any?
I want to say there's 2 of them.
You are right, Patty. And where are they?
First we gotta set. Let's walk this step by step.
Okay.
First we gotta set y to 0
Okay,
because
so that would
x
be right here.
intercepts where y equals 0.
Yep, that's right.
Cancel out the x plus 1 on bottom because anything multiplied by 0 just cancels out.
Yep.
And then we just solve from there.
So x would be,
-4. We
Yep.
have an one x intercept at -4, 0, and another at positive 2, 0.
perfect. Now we're done with important information, the important stuff. So now it's just a matter of, can you sketch in the curve? So can you sketch that in, given what you've got? Can you connect the dots? Well, I hope. You got 3 of them right here. So this guy's gonna follow that asymptote out that way and follow this one down this way. Now, don't forget, you still have a point over here. So does he kind of help you figure out what's going on? The curve's gonna follow out this way and follow up that way. That's not supposed to have that. I didn't put it. That would be better. Okay? What do you think about that? You all right with that? You okay? All right. You're gonna do one on your own. As soon as you bring it to me and show it to me, you're done. And you can study and whatever you need to do. But everybody's gonna do one. You can help each other, but I wanna see what you've done. I wanna see that you can do it. That you understand what you're supposed to do. So we are going to sketch. Let me find it. Alright, so let me make sure I copied that right. 1, 2, yep. Alright, so see if you can sketch that one. It's a big one, just like we just finished. So if you get stuck, it's exactly like the one we just did. The procedure will be the same.